No doubt. Go for IE register today. IE register today. Say like, what are the bits in IE register? EA dash ET2 ES ET1 ET0 EX0. IE register is interrupt enable register. IE register is interrupt enable register. What is the SFR value for this? Yesterday we said something. A8. Now, what this register does is, you have written? Now listen. What this register does is, if in this register EA bit is 0, then all the 5 interrupts are disabled. EA is enable all. There are totally 6 interrupts, right? What is the interrupt? How many interrupts? 6 interrupts. One is reset. That one is TF0, TF1. Next, TIRI together. In that, reset is non-maskable interrupt. You cannot disable reset. Please mention that first. In the previously, you have written the reset, right? Reset is non-maskable interrupt. You cannot disable reset. It is impossible. RST you have written, all the leaves that you have written, right? In front of that, like you just mentioned, maskable interrupt. In any controller, not only in 8051. ಏನು ನಿಂದು ಇಲ್ಲಿ ಬಾ. In any controller, reset cannot be masked. If it masks, then there is a big problem. If something happens, guys, listen to this. If something happens in a controller, what is the best way? Start from the beginning. Something going wrong thing. What do you do? Like start from the beginning. Go step wrong with some hardware or software. Is it clear? Right? So reset in any controller or any processor, it is not maskable. You cannot disable it. Rest of the interrupts can be disabled. Okay? For example, if this bit is 0, then all the other interrupts, INT0, INT1, the serial, timer interrupts, all are disabled. Is it clear? Is this clear? Please write it here now. This bit enable all equal to 0. Disable all 5 interrupts. If it is 1, enable. If it is 1, enable all 5 interrupts. When all the interrupts are enabled, then again individually you can enable and disable them. All the interrupts are enabled now. Now you don't want timer 2 to execute an interrupt. Then you can disable that individually. Is it clear? It is like main power supply. You have given the main power supply to the board. Now in the board you can individually turn on and turn off the fans or the lights. Similarly, it is like this. This gives a control. It is 1. This will all get excited so that like I can give a value to this, it will become 1, or if I make this 0, timer, 1 second. We will take this ET1. The timer 1 flag is, if I make this 0, timer 1, TF1 interrupt is disabled. Though all the interrupts are enabled, Is it clear? We'll write that also. Right. First, is it clear? Is this enable all is clear? Next one, this is reserved. Huh? 0. All the things will be 0. Except I told you, port 0 and SP, except, all the ports and SP, every other register is 0 by default. So by default, all the interrupts will be 0, not enabled. You should go and enable the interrupt first. Dash is reserved. Is for, ET2 is for timer 2, which is there in 8052, not in 8051. So you don't need to worry about this. So you just mention timer 2 in 8052. That means it is not there in your coverage area. Don't worry about this. Next, ES. Serial interrupt. Enable serial interrupt. Now should I write 0 and 1? I don't think so, right? Yes, listen here. If it is 0, then like serial interrupt is disabled. If it is 1, serial interrupt is enabled. Serial interrupt is there for both transmission and reception. There is only one interrupt together. Depending on the program, you should identify whether the data has been received or transmitted. This is for timer 1. This is for interrupt 1. This is for timer 0. This is for interrupt 0. So please mention it here only. This is for TF0. This is for INT0. This is for INT1. This is for TF1. This is for serial communication. This you have mentioned. If you put 0, they are disabled. If you put 1, they are enabled now. Register, yeah. There is one more register that need to be discussed. What is the value? One second. There is TCON. We'll try to discuss. Let us see. The another register which is associated is TCON. Right? TCON has 8 bits in which 4 bits will be displayed. TF1, TR1, TF0, TR0. TF1, TR1, TF0. IT1, IE0, IT0. Okay. This we will not discuss in today's class because we very well know like what is this. TF flag, TR flag. What is TR flag? Start a timer. TF flag is time overflow. For timer 1, timer 0. This we have studied in the previous classes, so we will not discuss this. What we have, do you remember when I said about something about this? We have written one statement. What is that? Edge triggered or low level triggered. This will become 0 if it is 0. If it is 0, it is level triggered. If it is 1, it is edge triggered. What is the edge and level here? Clock from where it is coming? This, if you do this right, if you remember the diagram for the timers, when we said like counter diagram, counter this, I have given you one diagram. Is it there in your test now? You have it right now. ಇದೇನೋ ನಿನ್ನ ಹತ್ರ ಇದಲ್ಲ. When we discussed counters, we had given one diagram, XTAL divided by 12 given to a mux. Remember that. The other part was T0 thing. Then like whole thing can be controlled using gate signal. TR0 is there and gate signal there. Remember those things? The structure it is there. See to that. It says pin number 3.2. Pin number 3.2. Now pin number 3.2, that is interrupt 0, will control what should happen to the timer. What should run? Let's listen. According to that diagram, if I enable TR01, already done, then I make it as a counter, then the control will go to the ENT0 or gate. Right? If ENT0 is 0, then timer will stop. If ENT0 is 1, then the timer will run. Structure. Above that you see there is a T0 P3.4 as a source. Counter source. Source is different from control. On-off control and source control. On that day we have marked. Upper part is source control. Below part is on-off control. So on-off control is in interrupt 0. Source control is in T0, P3.4. For counters I am saying, for counters. For both of this, when I make this IT1, they will act on the negative edge. In particularly T0. You said clock, right? It is not a clock exact. Clock for the counter, yes. From where it is coming? From the external source on to the pin T0. What is the pin T0 number? T3.4. On to this pin, if there is a negative edge, then this will take it as one clock, and then you are understanding this. Are you understanding this? These are all linked things. That is why I said microcontroller is not a subject to be studied like individual topics. You have to link all the topics and look at it as one individual entity, Then only we can understand the complete structure. If you know only this part, you don't know that part, like gone. Okay? Right? Have you understood this? On T0 pin, which will act as a clock for the counter, internal timer 0. This clock right now it is, or that counter right now it is negative edge triggered counter. If it is 0, it is low level triggered counter. Am I clear on this? Right? So please mention this IT1 once again. Thing is that whatever the value you give here will be appreciated if this is 1. If this is 0, there is no meaning for those 4. So this is a whole power supply controller is here. Only when this becomes 1, everything gets enabled. If this is 0, whatever you give there has no meaning. Okay? Right? Done. So, yeah, please mention this below. One, if tcon equal to 0.5, if tcon equal to 0.5, then INT0 and INT1, will be negative edge triggered interrupts. Negative edge triggered interrupts. Negative edge triggered interrupts only and only when IE register is enabled. You got it. External IE register is enabled. You have written that. Right. Next one. You know what is the meaning of 5 there? 5, Tcon equal to 5. Right. Both these are IT1 and IT0 are enabled. So that is why IT0, INT0 and INT1 are enabled there. Okay, what we do is we'll write it. If it is not clear, we'll discuss it again. Right now, what you do, write it, just write it. IT0 and IT1. IT0 slash IT1 implies, IT0 slash IT1 implies interrupt 0 slash 1 interrupt 0 slash 1 type control bit. Interrupt 1 is there. That type is controlled by this. If it is 0, it is low level triggered. If it is 1, it's the edge level trigger. This edge level or low level is the type of the interrupt. Right? That is why it is called type controlled bit. Right? Below that, set or cleared by software. Set or cleared by software. To specify. Set or cleared by software to specify falling edge or level triggered external interrupt. It is set or cleared by software. It will not happen automatically. To specify whether the interrupts are level falling edge triggered or same level triggered external interrupts. Below that, write next one. IE0 and IE0 slash 1. IE0 slash 1. That bit, IE1 and IE0. About that we'll write. Implies external interrupt 1 slash 0. 1 slash 0. Edge flag. External interrupt 1 slash 0 edge flag. Below that, set by CPU when high to low transition is detected. Set by CPU when high to low transition is detected. On INT0 slash 1. Okay, cleared by CPU or hardware, it is same. IT0 and IT1 are set or cleared by software. That means we have to write it. Set bit IT1 or IT0, we have to write it. For IE0 and IE1, they are set by hardware, cleared by hardware. You don't need to do anything. But when they will set, it is important. Set, you understood now? When there is a high to low pulse or a high to low signal on the INT0 or INT1, this will set. INT0 corresponds to IE0, INT1 corresponds to IE1. Clear CPU when interrupt is processed. Cleared by CPU when interrupt is processed. Below that, write note. This flag does not latch. Low level triggered interrupt. This flag does not latch low level triggered interrupts. That is why we said it as edge flag. This IE1 is INT1 interrupt edge flag. Whenever there is a high to low signal on this will set. High to low signal on this, it will set. For the IE0, it is INT0 flag. Whenever there is a high to low signal on INT0, this will set. right? You will only set it, hardware only set it. Then once there is an interrupt based on this interrupt, this setting, CPU does some function. After completing that function, CPU will only make this as 0. This as 0. Is it clear? That is what the statement says. Set by CPU when high to low transition is detected. Cleared by CPU when interrupt service routine is completed. Right? These two are meant only for edge flag. They are not meant for low level. Two types, right? This is type bit. If it is 1, it is edge. So whenever this is edge, then only this will work. If it is low level, it will not work. It has no meaning. Is it clear? Right? Next, what we have to do now is we have to write one small program very quickly. Yeah, this is nice. We'll write this. Yeah. Shall I rub this part? Now, is this part is clear? Any doubt in this 4 bits? For interrupt 1, IT0 for interrupt 0. This is a type setting bit, low level or edge. This is edge enable or edge flag. Whenever there is edge, it will detect that. Clear with this? Now, next. Okay. Generate a square wave at P1.3. Generate a square wave at P1.3, which is half the frequency of signal applied to INT0. Signal applied to INT0. First, did you got a question? Did you got a question? What this says? Okay. 1 second. 81 will enable the interrupt 0. Okay. I will try writing it here. For 8051, what is that? Port number 1.3. We have to generate a signal. The signal is applied to INT0. Let's see here. On this INT0, I have given one square wave. I don't know what is the frequency of this signal. I have to just generate half of this frequency in here. Half of this frequency in here. This is a question. I am giving one signal to INT0 pin. I don't know what is the frequency of it, but you have to write a program to generate a square wave on the pin 1.3, which has a frequency half of this. Right? That means, what is the sound? Utsav, they are testing. What is the simplest way? It is direct on our discussion now. Whenever there is a negative edge, you flip the signal. Flip this bit. Flip in the sense complement a bit. Right? How do we write a program is important now. Please, let's start with one more important point. INT0 is linked to which memory location in vector table? IVT, interrupt vector table. 003. Next one. 00B. 000B. Now you listen. Guys, listen. B, right? What next? What is next thing after this? Huh? TF0 IVT address is this. Correct, right? Next address I wanted. 3 to B. B is what? A, B. 11. 11 and 3. 8. So there are 8 bytes of space available for you to write a code. A code which runs a interrupt service routine. Normally what the people will do is they will just write LJump here. Which will go and sit in here has to be only 8 bytes. If it is more than 8 bytes, you are interfering in some other interrupt area. You are understanding this? ROM location, this is ROM. From the beginning it is 0, 0, 0, 0, 0, 1 and 0, 0, 2. The code is reserved for RST pin. If you press a reset, what should happen? Has to be there 3 bytes. You have to write only 3 byte line for this. So what you can write LJump. This is how many byte instruction? Chetan has a very peculiar character. If you say something to him, he will say something else. Here is how many bytes? Here is how many bytes value? 2 byte or 4 byte? 2 byte or 1 byte? What is the range of for LJump? Fixed value for here is FFFF. That is 2 bytes. This is 2 bytes. You should write anything about this because next area 003 belongs to this guy INT0. Whenever there is an interrupt on this pin, the PC will directly come here. This has been fixed by the designer. This interrupt vector table, there is an interrupt on reset pin. The PC will directly come to 00. All of you know this. Similarly, whenever there is an interrupt on interrupt 0, then it will come to the 003 directly. 3, right? 3 directly. And maximum it can go is up to 00A for interrupt. From here, this will start. Timer 0 will start. Timer 0 interrupt. This area is reserved for timer 0. Like that, when I say this area, that means whenever that interrupt rises, what you have to do has to be there in only this part of the code. If your code is beyond this size, then it is tested to use LJump to this. Have you where you don't need to call the function. When I say call a function, what happens? Listen. When I say call delay program you have written. Call delay, what happens? It will store the next PC value in the stack and go to that. Delay has some address. Go to that address and execute a program. When I say it goes to that address, meaning what? PC value will be updated from the next instruction to this instruction directly. Right? Then it will. Call is associated with return. When I say return, it will go to stack, fetch this address, put it to PC and execute from the point where it has left. Right? The same thing will happen. Now there is no call delay here. Delay address is fixed now. Delay address is fixed to 0000. Are you understanding this? Subroutine